Hey everyone, and welcome back. Today we're diving into a topic that's pretty mind-blowing, even for us. And we're used to this stuff. We're talking black holes.
Black holes.
But not just as those cosmic vacuum cleaners that you always hear about.
Right.
We're going way deeper, exploring how these incredible objects are actually like powerful energy engines that can shake entire galaxies.
Yeah, they're pretty amazing.
And to guide us on this journey, we have this fascinating article from the Astrophysical journal. It's called "The Secret Energy Inside Every Black Hole is More Powerful Than We Thought."
Catchy title.
I know, right?
And the research really backs it up.
So black holes might be releasing even more energy than we ever imagined. That's a pretty big deal.
It is. Potentially changes how we understand their role in the whole universe.
Wow. Okay, where do we even begin with something this complex?
Well, imagine a black hole
Okay.
spinning incredibly fast. I mean, so fast it's warping the fabric of space-time.
Okay, got it.
Now picture these strong magnetic fields like invisible strings connecting this spinning giant to the swirling disk of matter around it.
Okay, I'm picturing it.
That's the essence of what's called the Blandford-Znajek effect.
The BZ effect.
BZ effect.
Okay, so these magnetic strings are pulling energy from the spin of the black hole. It sounds like science fiction.
It does, doesn't it?
Yeah.
But that's the reality of these incredible objects. As the black hole spins, those magnetic fields get all twisted and stretched, creating this sort of cosmic dynamo.
Oh, wow.
And that dynamo is what extracts energy from the black hole's rotation and transfers it to the surrounding matter.
So it's using its own spin to generate power? That's wild. But I imagine studying these high-luminosity black holes, the ones with the really bright, thin disks of matter swirling around,
Yeah,
those must be incredibly difficult to study.
they are. Those systems are actually really unstable, theoretically speaking.
Oh, really?
You've got intense gravity, powerful magnetic fields, and everything's moving at crazy speeds.
Yeah.
It's a chaotic environment, almost like trying to study a tornado from the inside.
Yeah, that's a great analogy. I remember reading about Mitch Beagelman's research that suggests magnetic fields might be what stabilizes those wild disks.
Uh-huh.
Is this new research building on that idea?
Absolutely. Beagelman's work was crucial in helping us understand these magnetic fields. This new study takes it even further. It uses super sophisticated computer simulations to model what's happening around these black holes.
Simulations. So we're not sending probes into black holes twice yet.
Not yet.
Probably for the best.
We'll stick with the safer methods for now. These computer models, they're called 3D General Relativistic Magnetohydrodynamic Models,
3D general what?
or GRMHD.
GRMHD. Okay.
These let us peek into these crazy environments virtually.
So like virtual experiments.
Think of it that way. We can tweak things in the simulation like the black hole spin or how the magnetic fields are arranged. Then we see how these changes affect the whole energy extraction process. It's like having a front row seat to the most extreme physics demonstration in the universe.
That's incredible. So what did these simulations actually reveal about the energy coming from black holes?
They found that between 10% and 70% of the energy taken through that BZ process ends up in those powerful jets we see shooting out from the black holes. And it all depends on how fast the black hole's spinning.
So the faster the spin, the more energy blasts out into space, like a cosmic fire hose on overdrive.
Yeah, pretty much.
But what about the rest of that energy? The part that's not going into those jets? It can't just vanish.
Well, it doesn't disappear.
So where does it go?
It's a bit of a mystery, and that's where things get really interesting.
A mystery. Now you've got me hooked. I need to know where all that energy goes. So we've got this picture now of a black hole spinning like crazy magnetic fields, pulling energy out, and some of it blasting into space in these jets. But what about the rest of the energy, the part that's not going into those jets? Where's it going? It's like a cosmic energy puzzle missing some pieces.
Yeah, it's a puzzle that scientists are still working on.
Uh-huh.
One possibility is that that missing energy could be crucial for forming something called a corona.
A corona, like what we see around the sun during an eclipse.
Exactly, but on a much bigger scale, way more intense. This corona around a black hole, we think it gets heated to millions of degrees by all those gravitational and magnetic forces.
So this missing energy is like fuel for this blazing inferno.
That's one of the leading theories. Makes sense when you think about it. All that energy has to go somewhere. Some of it gets absorbed back into the disk of matter, but the rest could be going into this superheated corona, creating those intense X-ray emissions we see.
Wow, so like an invisible halo of superhot gas constantly radiating energy outward. It's hard to grasp the amount of energy we're talking about here.
It's mind-boggling, isn't it? And the study we're talking about, they found that these strong magnetic fields around these bright black holes could really boost what's called the radiative efficiency of the disk.
Radiative efficiency.
Yeah.
Okay, break that down for me. What does that even mean?
It's basically a measure of how well the disk turns matter into energy.
Okay.
or in simpler terms, how brightly the disk shines. What they found is that the magnetic fields make this process even stronger, making the disk way brighter than we'd expect.
So the magnetic fields are like cosmic amplifiers cranking up the brightness of the black hole's surroundings.
That's a great way to put it, and that could explain why some black holes look much brighter than our old models predicted. We might have underestimated their true energy output all along.
You know, it's funny, I used to think of black holes as these destructive things just swallowing everything up. But now it seems like they're creative too, influencing the formation of stars shaping entire galaxies.
That's a good point. Black holes are more complex than we first thought. They're not just sitting there in the dark.
Right.
They're dynamic things interacting with everything around them.
It's like they're part of this cosmic dance, constantly influencing and being influenced by their surroundings.
Exactly. And this research shows just how important they are in the grand scheme of things. The energy they release it ripples outwards, impacting the evolution of whole galaxies over billions of years.
Wow, so it's not just the black hole itself, it's the impact its energy has on everything around it. Can you give some specific examples of how this energy shapes galaxies?
Think about those powerful jets we talked about.
Uh-huh.
They travel huge distances carrying energy and matter with them, like a cosmic fire hose.
So they're not just pretty lights, they actually affect the galaxy in big ways.
Absolutely. The jets can heat up gas in the galaxy, stopping it from collapsing and making new stars. They can also cause shock waves that compress gas clouds, which could then trigger star formation in other areas. It's like this cosmic balancing act.
So the black hole is like a conductor of this cosmic orchestra directing energy and matter to shape how the galaxy develops.
Nice analogy. And remember that extra energy absorbed back into the disk or heating the corona, that also has a big role. It can create powerful winds that blow gas outwards, further influencing star formation and how matter is spread within the galaxy.
It's mind-blowing to think about the sheer scale of all this. We're talking about energy beyond anything we can understand here on Earth. And it's all driven by these mysterious objects that we're only just starting to understand.
It really is humbling, isn't it? It shows how much more we have to learn about black holes and what they do in the universe.
We've gone from thinking about black holes as just sort of these cosmic vacuum cleaners to these incredible energy engines that can shape entire galaxies. It's a whole new way of looking at them. But with all this talk about energy, it makes me wonder, are black holes all about destruction? Or is there a creative side to these cosmic giants?
It's a great question. It really gets at how complex they are. It's this fascinating duality, destruction and creation all mixed up in these incredible objects, and it shows how everything in the universe is connected. Black holes have this reputation as being these isolated things, inescapable, but really they're woven right into the fabric of the cosmos.
Yeah, like they're not just sitting there passively, they're actively participating in this grand cosmic dance.
Exactly. And the research we've been talking about today really highlights just how important they are. The energy they release, whether through those jets or the winds or radiation, it all ripples outwards, shaping the evolution of entire galaxies over billions of years.
Yeah, like a domino effect, the black hole starts this chain reaction that affects everything around it.
That's a great way to put it, and it really emphasizes why studying these objects is so important. The more we know about black holes, the more we learn about how the whole universe works.
This deep dive has definitely left me with more questions than answers, but in a good way. It sparked this sense of wonder and makes me want to learn even more about these amazing things.
That's exactly what we hope for. Science isn't about having all the answers. It's about exploring the unknown and pushing the boundaries of what we know.
So as we wrap up our exploration of black hole energy, I have to ask, what are some of the big unanswered questions that scientists are still trying to figure out? What mysteries are still out there?
Oh, there are so many. One of the biggest is about how those jets form. We know they're powered by the black hole's spin and magnetic fields, but the exact details are still up for debate.
And what about the corona? We talked about how that missing energy might be feeding it, but there's still so much we didn't know. It's like a puzzle with some pieces missing.
Right. What's its structure like? How does it change over time? And what role does it play in the overall energy of a black hole? These are all questions that are keeping astrophysicists busy.
And then, of course, there's the ultimate question, what happens at the singularity, that point of infinite density at the center of a black hole? Physics as we know it even work there? Are there other universes hidden inside?
Those might be questions we can never answer, but that doesn't mean we shouldn't ask them. It's those big, impossible questions that drive scientific progress and make us keep exploring.
Well said. So our deep dive into black hole energy might be ending here, but the journey of discovery definitely doesn't. Who knows what amazing discoveries are waiting for us as we keep exploring these cosmic wonders.
Maybe one day we'll even figure out the ultimate secret. Could black holes, with all their energy, be the key to powering future civilizations? Could we use their power to travel across the vastness of space? It's It's a pretty exciting thought.
It really is. The possibilities are truly endless when it comes to the universe and its mysteries. Thanks for joining us on this incredible journey.